Hey, all, Brad here with another video. On the bench today, I've got a full Defender board set. I believe this is out of Cocktail Game. Um, Same customers I did the Matrix board for that I still have, Jennifer. I've done a lot of work with her in the past, and she sent this over trying to get these games finished up. I also did a Joust ROM board that she had, so I went through and completely rebuilt that. So I'll go over what I did on the boards. We'll do some gameplay and get this video wrapped up. Turned out real good. Let me switch over to the bench cam. One of the things she shipped over was the overvoltage protection board. So this is on the early power supplies it's made for. The newer ones like this have the overvoltage built on the board, but the Defender, early Stargates, Make Track, some of those with the one piece where the heatsink, the power transistors are all on the same board. They did not have overvoltage, so they had these little add-on boards. So I cleaned the pins up, straightened it out, and tested to make sure everything's working good on it. Soundboard had quite a few issues actually. Again, I go through these. I change all the electrolytic capacitors, bridge rectifier, all the Molex headers with the square pins. This one had the audio amplifier, the TDA 2002 was bad, and there was also a 4068. This is a multiple AND gate was bad. A couple other issues on it, but put new heatsink compound under the voltage regulator, pulled the fuses and cleaned those. Um, Working real well now. Over here on the ROM board, no big smoking gun on this one. It did get a new filter cap, all new Molex headers with the square pins. All the EPROMs got pulled, legs straightened and cleaned. Everything on the board was polished. New ribbon cable installed that I make up all 3M parts. IO board, new ribbon cable, new filter cap, two new 10-pin Molex headers. And if you notice here too, the serial numbers on these all match. So that's ending in 522, soundboard 522, ROM board 522, and then we'll make our way down to the MPU. Now the MPU was pretty roached from battery acid damage, so I used a donor board I had here, stripped it down. This board actually had a couple parts that were bad that I swapped off the one that had the corrosion damage. So, and I did move the original label over the serial number so they're all matching, and is the exact same model board version. New Molex headers, new filter caps, put a 22 microfarad tantalum here for the soft start. I did change out the Zener diode here, ZR2 for the 5 volts. Original was 3.9. This is 4.7. So again, it will pull the board into reset anytime it gets to 4.7 or below. And let's see what else. The decoders were from the original board as well. I did put new labels on them, reproduction labels. The CPU is from the original board. This reset switch actually was cracked on this board, so I took the one off the other board. Um, Working great on this one. And the RAM is all AM, which is AMD RAM, all matching, really nice on this board. The battery holder was on here for the double A's. It had some damage on it, no real corrosion got onto the board, but I ended up swapping that out with a new battery holder. And these are the Energizer Ultimate lithium batteries, so there's zero chance of them, you know, off-gassing hydrogen or leaking alkali on the board, causing acid damage. These are a really good solution, and I'm kind of a purist, so I like the AA look. The CR2450s are great too, especially for the newer boards. But these Defenders, they use a 5101 CMOS, and the standby current, depending on the model, is a little higher. Than what we see on the Joust Robotron series board. So that CR2450, while it'll last quite a while, it won't be 15 years like it will on the other board. So with these AA lithiums, it'll last a long time. So with that, I'm going to switch back over and we'll boot the board up and do a little gameplay. Also here's the Joust board that I restored. This turned out real nice. It's in a pink anti-static bag, but pulled all the chips, cleaned all the legs. Everything got reproduction labels, including the blitters here, new ribbon cable, electrolytic filter caps. All the headers are new. This board got stripped down, simple green bath, and it did test burn on the bench for 24 hours. It ran no issues at all. So that one's going back as well. Let me get situated here. Okay. What we've got up there is just some artifacts from the last time I ran the game. So here's a little remote control power switch. I'm going to go ahead and turn it on. Should be getting the audio along with this, hopefully. System okay. And boots right into a track mode. So that tells us the battery, all the diodes, CMOS RAM, everything's holding the memory pretty good there. So I'll add a couple coins. Again, I have the PlayStation controller mapped out for Defender here on my harness, and I can go through and do a little gameplay. I think I've mentioned in a few of my videos that I'm much better at fixing these boards than playing them. So, again, playing with this little PlayStation controller is just kind of is it's kind of tricky. I think what I'm going to end up doing is I'll program for the fire button here to make it like a rapid fire where I can just hold it and it'll send out a lot. I can easily programmatically do that on that board. So she's working real good. I'll do a hyper. I'll do a smart bomb here. Hyperspace is what I did earlier. Got me. Well, that's good because this on Defender is one of the few games that if you're in the game, you can't go into the diagnostics. So I'm going to go ahead and drop into diagnostics here. So all ROM's okay. That basically checks all the checksums on Defender has 11. ROM 5 is not used, so it has 11 out of the 12 that are used. And then RAM test, you can let this run and it'll go through and run, that you visualize it as the carpet pattern, but it's actually writing random data out to the RAM, reading it back and verifying with what it wrote. And those random bits, anything in the RAM gets rendered out to the display. So you're actually seeing the random bits that are being set there. So no RAM errors detected. That's testing the CMOS is good. We can go through the colors test. So you'll see 3 intensities here. You see the light, a little brighter, and then 3, and then it'll go to green. You'll get 3 intensities here. And then blue, you'll get 2 intensities. Again, they had 8 bits to work with, so they used 3 for red, 3 for green, and 2 for blue. And then this will go through on Defender without doing anything. It'll loop through all the sounds. Instead of just going through 6 to test each digital input, it goes through all 32 of them or 31 of them. So I won't bore you with all of them, but they're all working. And then we come to the switch test, and I actually like the switch test on Defender better because as you do each individual one, they're at the top, where on all the other test screens, they fall in a specific location in a list, essentially. So here, though, as you're doing them, you can do multiples here, so they'll stack. But if you're just doing one at a time, it'll be at the top. So you can see everything's working great. There's reverse, hyperspace, smart bomb for player 1. I did go through, actually, because I believe this is a cocktail, the board set came out of. So I did go through and test all of the inputs for player 2 as well, separately with a jumper to ground. I didn't really, at the time, want to map them all to the controller. So, and then you can go through and do some monitor test patterns, and then back to the track mode. So with that, this board has had 24 hours running on the bench, and I'm going to get this out and get everything in anti-static bags and bubble wrapped and packaged up coming back to my customer. So thanks for watching the video, and we'll see you on the next one.